For years, this channel has explored the edges of reality, stories of people who seem to know events before they happened. Artifacts that appear centuries ahead of their time, footage that refuses to behave according to known physical or historical laws. But almost no one ever asks the most important question: how are these mysteries even found? In the modern world, reality is recorded constantly, not occasionally, not selectively. Constantly. Every street corner, every sky, every disaster, every archaeological site, every anomaly caught by accident. Satellites orbit the planet day and night, capturing terabytes of imagery. Security cameras record billions of hours of footage annually. Smartphones document everything from daily routines to once-in-a-lifetime events. Archives digitize centuries of documents, maps, photographs, and films. Humanity no longer lacks information. It is drowning in it. The age of mystery did not end because secrets disappeared. It changed because the volume of data became impossible for humans to process. Hidden inside this ocean of information are anomalies, rare moments where reality doesn't behave as expected. But the problem is simple. The human brain was never designed to scan billions of data points looking for statistical impossibilities. Our minds evolved to recognize patterns at a human scale. Faces, movements, threats close enough to matter immediately. We are excellent storytellers. Terrible data filters. This is where artificial intelligence quietly entered the investigation process, not as a creator of mysteries, not as a believer in the paranormal, and certainly not as a replacement for human curiosity. AI entered as a filter. Unlike humans, AI systems do not experience boredom. They do not get tired. They do not lose focus. They do not dismiss things because they feel unlikely. They learn what normal looks like. An AI trained on millions of videos learns how crowds usually move. An AI trained on architectural datasets learns how structures are typically built in different eras. An AI trained on historical imagery learns what objects, materials, and behaviors belong to specific time periods. From this, the machine constructs a statistical baseline of reality. Not what should happen, but what usually happens. Once that baseline exists, anything that deviates from it becomes visible. A stone block cut with precision far beyond what tools of its era should allow. A motion pattern in footage that doesn't align with known physical constraints. A historical record whose structure doesn't match surrounding documentation. These are not judgments. They are outliers. AI does not label something as impossible. It labels it as improbable beyond expectation. That distinction is critical. Many of the most baffling cases explored on this channel were first flagged not by belief, intuition, or conspiracy, but by algorithms quietly identifying data points that didn't statistically belong. No drama, no narrative, just numbers refusing to align. To a human, an anomaly might look ordinary at first glance. To an AI, it stands out immediately. Because AI does not see stories, it sees distributions. And when something falls far outside the distribution, it demands attention. This is how modern mystery investigation often begins. Not with legends or rumors, but with the machine asking a very uncomfortable question. Why does this exist here, now, and in this form? AI does not care about reputation. It does not care about established narratives. It does not care about what historians, scientists, or experts expect to see. It only measures deviation, and deviation is where mystery lives. This doesn't mean AI understands what it finds. It doesn't. AI does not know meaning. It does not know intention. It does not know truth. But it is exceptionally good at pointing to places where truth may be incomplete. In Manikas's anomalies flagged by AI, sat unnoticed for decades, archived, catalogued, and ignored, simply because no human had reason to look at them closely. The data was always there. What changed was the intelligence examining it. This marks a fundamental shift in how mysteries emerge in the modern era. In the past, mysteries began with eyewitnesses, then rumors, then stories. Today, many mysteries begin with algorithms quietly raising a flag in a database. No human could ever fully read. This is not about replacing human judgment. It's about revealing where human attention should be focused. Because the most unsettling realization is this: Some of the strangest mysteries of our time were never hidden. They were recorded in plain sight, waiting for something that never gets tired, never blinks, and never stops comparing reality against itself. And once those comparisons begin, reality starts to look far less stable than we thought. Artificial intelligence does not understand the world the way humans do. Humans think in stories, causes, intentions, and meaning. AI thinks in repetition, probability, and deviation. To a machine, reality is not a narrative. It is a data. When AI systems are trained, they are exposed to enormous volumes of information, images, videos, architectural records, historical artifacts, motion patterns, and physical simulations. From these repetitions, the machine learns what the world usually looks like. Not what should happen, but what typically happens. Over time, AI builds a statistical baseline of reality. This baseline defines how often certain structures appear, how precise ancient construction normally is, how objects usually behave under gravity, and how people typically move across time and cultures. Once this baseline exists, anything that deviates strongly becomes impossible to ignore. This is the core principle behind how AI detects anomalies. AI does not label something as supernatural or fake. It labels it as unlikely, beyond expectation. Imagine analyzing millions of examples of ancient stone construction. Most fall within predictable tolerance ranges. But when one structure displays precision far beyond those ranges, it stands out instantly to an algorithm. To a human, it may simply look impressive. To AI, it is statistically abnormal. This same logic applies to video analysis. Modern AI systems can break footage into thousands of frames and examine each one independently. They analyze lighting consistency, shadow behavior, motion trajectories, and pixel-level noise. If an object or movement behaves in a way that does not match known physical models or camera artifacts, the system flags it, not as proof of something impossible, but as something unexplained. Humans often miss these details because we focus on the overall story. AI does not. It focuses on deviation. Another unsettling capability of AI is its ability to compare anomalies across completely different domains. Archaeology, physics, signal analysis, and historical records may seem unrelated to us, but to an algorithm, they are all structured data. Patterns can repeat across fields. A geometric ratio found in ancient architecture may mathematically resemble a pattern detected in unexplained signal noise. A symbolic structure carved into stone may match statistical distributions found in unrelated datasets. AI does not claim these similarities mean anything. It only shows that they exist. And when patterns repeat across time and geography, coincidence becomes harder to assume. One of AI's most disruptive traits is neutrality. It does not respect authority. It does not care about historical expectations. It does not know what experts believe should or should not exist. A 2,000-year-old artifact and a modern object are treated the same way as data points. If their properties align, the machine does not reject the comparison. It flags Italiano. This neutrality allows AI to expose blind spots created by tradition and assumption. But it also creates discomfort because it surfaces questions that challenge established time. Still, AI cannot interpret meaning. It can point to what deviates, but not why it matters. That responsibility remains human. Historians, engineers, physicists, and skeptics must take the anomaly and attempt to explain it. Most are eventually resolved. Some are not. Those unresolved cases are not mysteries because AI believes in them. They are mysteries because our current models fail to fully absorb them. That is the true role of AI in uncovering the unknown. It does not invent mysteries. It applies pressure to our understanding, and where that pressure causes cracks to appear, mystery quietly emerges. Time is one of the most unstable things humans try to understand. We experience it subjectively. We remember it imperfectly, and we reconstruct it using assumptions more than evidence. Artificial intelligence does none of that. For an AI system, time is not a feeling. It is data. When AI analyzes video, it doesn't watch events the way we do. It dissects them. Frame by frame, pixel by pixel, every microsecond accounted for. This allows machines to notice inconsistencies that human perception simply cannot register. Lighting that shifts in ways that don't match the sun's movement. Shadows that move independently of their sources. Objects that appear for fractions of a second without any detectable transition. To the human eye, these moments vanish inside motion. To AI, they stand out immediately. One of the most powerful tools AI uses in time analysis is motion modeling. Every object in a video is tracked through space and time. Its speed, acceleration, and trajectory are compared against known physical constraints. When movement violates those constraints, even subtly, it becomes visible. Not as proof of time travel, not as proof of manipulation, but as evidence that the event does not behave as expected. AI also analyzes temporal continuity. It checks whether cause and effect align properly across frames. If an object moves, the environment should respond. If something appears, it should cast a shadow. If time progresses, entropy should behave predictably. When these relationships break down, AI flags the sequence. What makes this unsettling is that many of these anomalies exist in footage long considered ordinary. Archived videos, historical recordings, and early film stock material no one thought to question. Only when modern AI systems revisited these recordings did temporal irregularities emerge. Not dramatic glitches, subtle ones. The kind that escape casual observation. AI also compares recordings across time. If multiple videos from different sources capture similar anomalies, similar timing irregularities, similar motion discontinuities, patterns begin to form. Patterns suggest repetition. Repetition challenges. Coincidence. Importantly, AI does not conclude what these anomalies mean. It only shows that they exist. Most are eventually explained. Old cameras, compression artifacts, human error. But a small percentage remain unresolved. Not because they prove something extraordinary, but because no explanation fully accounts for every variable, and those cases linger. Another critical advantage AI has is patience. Humans grow tired of uncertainty. We want answers quickly. Machines do not. AI systems can reanalyze the same footage thousands of times under different models, different assumptions, different constraints, without fatigue. Each pass removes some explanations and reinforces others. What remains at the end is not a conclusion. It is a boundary between what we can explain and what we cannot. AI does not push beyond that boundary. It simply marks it. And marking boundaries is one of the most powerful things science can do. Because once we know where understanding fails, we know where investigation should begin. This is why AI has become such a valuable tool in exploring mysteries related to time. Not because it proves impossible events occurred, but because it reveals how fragile our assumptions about recorded time really are. Time, when examined closely, does not always behave as smoothly as we expect. And when AI shows us those fractures, we are forced to confront an unsettling possibility. Not that time is broken, but that our understanding of it might be. Humans are natural storytellers. When these datasets are translated into mathematical representations, AI can analyze them side by side regardless of origin or historical context. In some cases, AI has revealed clusters of anomalies that span centuries, not because they share a story, but because they share mathematical structure. Material compositions appearing far earlier than expected. AI also excels at eliminating noise. Human researchers often focus on dramatic outliers. They are consistent. This is how AI shifts the focus of mystery research. By now, it may sound like artificial intelligence is on the verge of solving every mystery humanity has ever encountered. But this is where one of the biggest misunderstandings begins. AI does not discover truth. It discovers deviation. An algorithm can tell us that something doesn't fit, but it cannot tell us what it means. Meaning is something AI does not possess. Artificial intelligence has no sense of history, morality, or consequence. It does not understand culture. It does not understand symbolism. It does not understand why a discovery would matter to humanity. It only knows that something is statistically unusual. This is why AI alone cannot solve mysteries. It can point, it can highlight, it can pressure our models. But interpretation still belongs entirely to humans. Every anomaly flagged by AI eventually lands in human hands. Historians analyze context. Engineers examine feasibility. Physicists test constraints. Skeptics search for errors. Without this human layer, AI output would be nothing more than endless lists of irregularities. Fascinating, but meaningless. This is where collaboration becomes critical. Humans bring narrative understanding. We understand timelines. We understand intent. We understand how discoveries affect belief systems and societies. AI brings something we do not have. Endless attention. It does not get bored of uncertainty. It does not rush to conclusions. It does not feel discomfort when explanations fail. Humans, on the other hand, crave closure. We want answers quickly. We want stories to end cleanly. AI does not care if a mystery remains unresolved for years. It will continue reanalyzing, recomparing, and refining models indefinitely. This difference creates a powerful tension. Humans push toward meaning. AI pushes toward precision. Where those two forces meet, investigation deepens. This is also where ethical responsibility enters the picture. AI can surface questions that society is not ready to confront. Challenges to historical time, contradictions in scientific assumptions, patterns that undermine long-held narratives. But deciding how to present these questions, when to explore them, and how far to push them is a human responsibility. AI has no concept of impact. It does not understand fear. It does not understand belief. It does not understand trust. Humans do. That is why AI does not replace investigators. It reshapes them. The role of the human shifts from discovering anomalies to interpreting them responsibly, from searching blindly to asking better questions. This collaboration also protects us from one of the greatest dangers of mystery research: overinterpretation. AI can surface thousands of anomalies. Most will have mundane explanations. Humans must decide which are worth deeper investigation and which are statistical noise. Without human skepticism, AI-generated mysteries could spiral into misinformation. Without AI precision, human curiosity could remain blind. Balance is essential, and this balance is what defines modern mystery exploration. Not belief versus disbelief, but data versus meaning. The most powerful insight here is this: AI does not threaten human curiosity. It amplifies it. By removing noise, highlighting boundaries, and revealing where models fail, AI allows humans to focus on the most meaningful questions, not the loudest ones. And as this collaboration deepens, the nature of mystery itself begins to change. Mystery no longer lives only in the unknown. It lives in the gap between what machines can detect and what humans can understand. For most of human history, mystery meant missing information. We didn't know what was beyond the horizon. We didn't know what caused the storm. We didn't know what happened before written records. Mystery was born from absence, but something fundamental has changed. Today, mystery is no longer defined by what we lack. It's defined by what we have too much of. Too many images. Too many videos. Too many records. Too much data for the human mind to fully absorb. This is where artificial intelligence quietly transforms the nature of mystery itself. AI doesn't remove the unknown from the world. It compresses the noise around it. By filtering billions of data points, AI exposes places where reality behaves inconsistently, not dramatically, but subtly. And subtle inconsistencies are often the most unsettling, because they don't announce themselves. They hide in plain sight. When AI highlights these fractures, it forces us to confront a difficult realization. Our models of reality may not be wrong, but they may be incomplete. For centuries, progress meant refining explanations. Today, progress often means discovering where explanations fail. AI excels at this. It doesn't confirm what we already believe. It reveals where belief stops working. This changes how mystery is approached. Instead of asking, "What strange thing happened here?" we now ask, "Why does this data refuse to behave like everything else?" Instead of chasing legends, we analyze patterns. Instead of speculating wildly, we narrow uncertainty. And paradoxically, the more precise our tools become, the more unsettling the unanswered questions feel, because they survive scrutiny. Another quiet shift is happening as well. AI is removing the illusion that mystery lives only at the edges of reality. In remote places, in ancient times, in extraordinary events, in truth, anomalies are everywhere. They were simply drowned out by noise. AI doesn't invent new mysteries. It reveals how many were already there. Unnoticed, unexamined, ignored. This leads to the final secret. The most important role AI plays is not in solving mysteries, but in redefining what mystery is. Mystery is no longer the opposite of knowledge. It is the boundary of it. A boundary that moves as our tools improve. Every time AI sharpens that boundary, it reminds us of something deeply human. Understanding reality is not a destination. It's a moving edge, and as long as that edge exists, mystery will exist with it. The future of exploration will not be driven by belief or disbelief. It will be driven by collaboration between human curiosity and machine precision, between meaning and measurement, between what we can detect and what we can truly understand. If you want to continue exploring that boundary where data exposes cracks in reality, where science meets uncertainty, and where the unknown is no longer hidden but quietly revealed, subscribe to because the greatest mysteries of our time are no longer buried in the past. They're already recorded, waiting to be noticed.